Is that the one, Mr. Jones?
Yes. Please go ahead. Thank you very much. Good morning, everybody. Thank you for your presentation. And my presentation concern the title is Pumping and Dressage System Optimization for Sharf al-Aqab Aquifer in Morocco. But the reason of this presentation is to share with you the role of groundwater and artificial recharge for utilities. I am from, as has been said, from ONI, which stands for National Office for Electricity and Drinking Water. This office is the main operator for drinking water. So we are responsible for water planning at national level, and we are producing more than 80% for drinking water in Morocco. That is mean we are responsible if there is problem in cities, even we are not charged in distribution, we are responsible because we are planner and also producer of water. Why I choose this case of Tangiers? Its original case, I will present aquifer and tell you which story we live and we have, and the utility and useful of this groundwater to supply cities, strategic cities as Tangier, with touristic and industrial cities. The outline of my presentation, I will introduce, put you in the general context, and then I will present the aquifer and present the work and the study we have done. Also, it's very interesting to share with you this experience to employ university with utility and the value added with the research and with researcher and with the academic domain, the added value for the operational and for utilities. And I will conclude. So the Tangier is located at northern of Morocco. It has population more than 1 million. And the complex of Tangiers, Azila cities, and ports of Tangier, which is the biggest in the Mediterranean region, are supplied by surface water and surface water. So we have 2 dams, Ibn Battuta dams reservoir and 7 April dams, and we have here an aquifer. And this aquifer, in terms of quantity, it's not very important as storage. The dam are given more than 90%, but it has a very strategic role. I will tell you a story. In 1995, we have known a very severe drought, and the 2 dams was empty. And for us, it's impossible to let Tangier without water, because it's as touristic. If we give not water, people don't, tourists don't return, and also there is industrial. And we was obliged to bring water by ship from south of Casablanca, almost 400 kilometers by ships. And all these ships give only, because we have technical limitation, only 50%. And the other 50% it was given by this aquifer. The amount, the cost of the ship was at this time $25 million. That is mean that we have saved a cost by using this aquifer 25 million. But, or of course, because it's hidden, all people talk about supplying water of Tangier by ships, and they forget to talk about this strategic aquifer, which is Shaf al-Aqab. So, how we use? We take water from the two dams, we treat water, and the surplus, the excess, we recharge it. So we make artificial recharge with treated water, with drinking water. And for many people, it will be, so it's costly, but when I give you this history, how we save if there is a problem, it could be drought, but also it causes pollution accident. We go to use this aquifer for small time, short time, 1 month, 2 months, etc. So the question asked for, as this time I remember, I was a young engineer, and we have a big meeting, stressed, and the CEO asked how much we can pump from this aquifer. I remember this day, my answer was, God say, Allahu A'lam, because we have not much data, we have not model of this aquifer, and we don't know how much. We know how we inject, we recharge, but we don't know what is the maximum we can have in this short period. So I still remember this. When I moved to the R&D department, the first I start by working on this aquifer, because it's still very important as strategic reserve for us. How to move. Oh, okay, okay.
No, I don't know if this is connected to it or not, but I think, okay. That
Okay,
is
okay,
connected.
okay,
Just
okay,
put
okay.
it-
This one, okay. So just to give you an overview on the regional context. So at hydrologic level, we have 3 basins called Mharhar, Hashif, and Wad Iyasha River. And in this river, we have these 2 dams, and we have the aquifer. At geological level, the aquifer is in the quaternary area. At its most, the soil is most sandstone and geocalcarinate and coarse sand. This is a typical sample of well we designed in this aquifer. Here is the subdivision of the aquifer. When we did this study, we made with the Mohammedia School geologic study, hydrological, and we make modeling, and we try to make this subdivision to build a conceptual model, and we have 3 subdivisions into 3 formation, 3 aquifer. There is the upper, intermediate, and the lower. And the most interesting is the lower aquifer. It's work as confined aquifer here, but it's unconfined, and we do artificial recharge from here. And the question to answer for this study, first we should have all the information, the extension of the aquifer, what is the depth, what is the evolution of the water table, etc. That is, we put it in GIS, Geographic Information System, and also what is the maximum we can pump, and where we can drill the wells, and what is the maximum of injection. Here is some data concerning the area and the volume of the aquifer. And as we can see, the more important is the lower aquifer. With this volume, so what typically by making water balance and calculating the storativity coefficient, we can have this 20,000 million cubic meter. Here is the variation of water table, a special evolution. The same. Here is the temporal evolution in one piezometer, reference piezometer. Here are the system of the drilling, the well and the pipeline. So all boreholes we used. Here that answer after study that give us answer of the question, storage versus drawdown. How you can get the water versus the drawdown you can do. Here they are the Rochelle system. We have 12 pits. I can show you the photo, 12 pits. So we use this interstice percolation, but we have also some fault and channel porosity in the northern of the aquifer. And the maximum we can have, it's almost 400 liters per second after the modeling. Here you can see the water. It's treated, cleaned water that we recharge in the basin. Here the basin are empty, are full. And the study, the question, after modeling and doing GS, it led us to have, instead to have a lot of borehole, we should concentrate in the center, in the blue zone. It gives the optimum for drilling. It's the same, it gives you this favorable zone. And also we have here what we call a quarry used to extract sandstone. We find that it can be used also to add some recharge, but the problem is a protection and vulnerability problem. And thank you very much for your attention.
Thank you very much. I think that one of the most important principles in the groundwater governance vision and framework was in fact the characterization of aquifers. That's the importance, how important it is to characterize aquifers and to know the geologic and the water and all of these issues. So I think this is a very important step toward achieving governance of the aquifer, knowing the resources in there, and then starting to develop it hopefully in a sustainable manner. Our next presentation, in fact, is a joint presentation. It is between Mr. Matt Kennedy, and should just give me a second. Mr. Matt Kennedy, who has about 25 years of experience in applying smart technology to solve customer challenges. He carries out the AquaShare mission to create equitable and resilient conservation markets with local groundwater agencies. building on business management and engineering roles in the aerospace and data networking sectors. Matt has been a general manager of a product group in SunPower Corporation, leading a leading U.S. solar product and project developer, guiding team to achieve technical innovation of the world's power infrastructure and improve global sustainability. The presentation also is co-authored by Mr. James Workman. Mr. Workman has about now 2 decades of field experience studying resilient societies in Africa, Asia, and the Americas. He is a pioneering writer and entrepreneur in the design of equitable conservation market for freshwater and marine resources. As a founder of the online water saving trading platform, AquaShares, he has helped establish water markets in California and Morocco involving hundreds of users, and is now calling on his experience to aid California GSA and their basin GSA is the groundwater service. Okay. GSAs and their basin stakeholders in designing and operating cap and trade market to better comply with the SGMA, which is the regulation for California for groundwater, currently in California, SGMA. Prior to establishing these markets, he was a deputy director of the Environmental Defense Fund Solution Center for Fisheries Market, launched the International Water Association magazine, The Source, and was a senior advisor to the World Commission on Dams under Nelson Mandela, and has served as the White House appointed speechwriter to U.S. Interior Secretary Bruce Babbitt, who was known for his zeal for conservation. And in fact, without Governor Babbitt at that time, the Arizona Groundwater Management Act would not have happened, if I am correct, on these issues. I would like to welcome James to the podium to give the presentation. This one?
Yeah, or I can, yes.
Oh, yeah.
All right. Well, that was a wonderful introduction, and I think a lot of you are wondering, wait a minute, we're here at a water conference. This guy is not a hydrologist. He's not a chemist. He's not an engineer. What does he know about water? And I don't know the physical aspects of water like anyone here at this conference. What I've been working on is finding ways not to manage water, but to